Yes. Ah, okay. See, I can hear myself. Mic works. There we go. Good morning. Thank you for coming out at 8:30 on a Friday morning. I know most of you probably had other plans for Friday morning, and I can respect that, so I'll keep it short and steady for this morning. So, welcome to the Mobile Devices Deep Dive for Lync 2013. I'm Cornel Burns. So for most of you some of you have been to one of my sessions before. If not, there's another one at 12. I'm from Houten, the Netherlands. I could have driven here. I work for Microsoft. I work for the Communication Center of Excellence. My daily job is to drive Lync business, make people happy about Lync, tell people about all the cool stuff that Lync can do. I'm a certified master in Lync 2010, certified solution master because we changed the name for 2013. That's me at Disneyland at the top right bottom, or the bottom right. It's really bad. For some reason I suck at taking pictures of myself, so it's the only decent picture I had. And I had this little thing I needed to fill in the top right, so I took one of my Lego Star Wars sets. I collect them, so if you have any spare ones lying around, feel free to email me, kburns@microsoft.com. It's also my SIP address, so if you ever have any questions or whatever, you can email me, ping me, disturb me. But that's me. So for today, I'll try to keep this within an hour and 15 minutes. Oh, the timer works again. So that's fantastic. So now we can actually see that we can keep it within an hour and 15 minutes. The 3 points I want to talk about today. What's new in Lync Mobility? How do we plan and deploy this new Lync Mobility, specifically for 2013? And some of the architecture. We get a lot of questions about why do we have a reverse proxy for Lync Mobility? Why do I need this when I just got internal clients? What's happening? How do the clients sign in? I don't have auto discover. Does my client still work? Questions like that. And I'd like to answer those today. I'll make sure that we get this done with like 5 or 10 minutes to spare, so you get all the time you need to ask any questions you might have. Some questions might be answered during the presentation, so I'd like to ask you to hold the questions till the end. And we can try to get a structured approach today. It's Friday morning for me as well. So, mobility overview. So, when we launched Lync 2010, we talked a lot about, well, there's mobility coming. And that was entirely truthful, because mobility was coming. It took us a while, but we got the ball rolling in the end, and we got a mobile client. And we took a look at that client when developing for Lync 2013, and we thought, well, what do we need when we launched this platform? So one of the things we wanted to do was true cross-platform support, so whether you'd have an Android phone or an iPhone or an Android tablet, an iPad, a Windows tablet, whether you were using a web app or a full PC, Lync should just work. Lync should feel the same, Lync should work the same. And then we took a look at the mobile platform specifically, and we saw that, well, there are some constraints. We need to make sure we take all our mobile platform has a limited battery life. You're not walking around with your charger all day and charging it every opportunity you get. When I use my phone, I want to charge it in the night, and I want to be able to use it the entire day. Lync shouldn't be draining my battery, like the mobile platform did at Windows 6.5 for a while. Deployment should be simplified. So for those that have deployed Lync Mobility on Lync Server 2010, I apologize. That wasn't the easiest deployment. We fixed that. And one of the most requested features, we want real-time communications. We want VoIP, video, desktop sharing on the mobile platform. So we listened and we built all this in our mobile app. So our new Lync will work cross-platform. So if you haven't tried the Lync web app, try it. It's really cool. You get whether you're on a PC or a Mac, you get a full Lync experience. So audio, video, desktop sharing, PowerPoint sharing, everything just works. Whether you're a local admin or not. It works on an iPad, on an iPhone, it works on an Android tab, it works, of course, on the Windows Surface or any Windows tablets, iPhones, iPads, Windows Phone 8, Windows Phone 7.5, whatever, you can use Lync. That's our main message. Whatever you're using, you can use Lync and real-time communications. So when designing for Lync, and you'll see some of these in our deep dive a bit more about what we've done to look at this. There are 3 major constraints when developing for a mobile platform. So the first thing is you've got disconnected apps. And that's sort of a twofold thing. First of all, apps don't work together on a mobile platform. So on your PC, you've got your Lync and you work with your browser for SharePoint, and for OWA, you work with Outlook for presence in emails. On your mobile platform, you've got your app. That's it. So we can't rely on the mail app or the calendar app for meeting invites. We have to make sure that this is in our app. The second disconnected apps that we have to, second part that we have to take into account is when you click away that app, it doesn't go to the background, it hibernates. So your app is disconnected for your server. We need to take that into account when designing for Lync. Low battery budget. If someone has a mobile phone that lasts for 12 hours, we now install Lync, and that person doesn't really use Lync. He IMs a little bit and he sees a presence, doesn't really use it for voice and video. And now that battery life goes from 12 hours to 6 hours, Lync is the first app to go. It's as simple as that. So we need to make sure that whatever we do, we don't drain the battery unless someone's heavily using that app. Someone that's doing a 4-hour video call on a mobile phone, yeah, I'd expect that battery to be drained by them. And the final thing, we have to be as efficient as possible with the data plan. So with the mobile clients, while we potentially, with the new dual cores and quad cores you see in mobile phones and the quick Android phones and quick iPhones, we could potentially do any form of fancy codecs. We've decided to use Siren, which is a really low usage codec where you'd actually get the most bang for your buck in terms of acceptable audio quality and acceptable data usage. Same for sharing content. We've made some optimizations there to make sure that when you're using the Lync app, it doesn't use more data than you need to, because most of us will be paying by the, well, the Netherlands they just introduced paying by the kilobyte, which is fun, so I'd like Lync to use as less data as possible. So far for the marketing stuff. Now the more interesting stuff. So when we started out with Lync 2010 and Lync 2013, there was no real mobility. So some of the new things, we talked a lot about mobility is coming, and the first things we did that had something to do with mobility with Lync 2010 was, well, you can still use the old mobile apps. And with Lync Server 2013, we said, well, you can use the web app and the old mobile apps if needed, the Lync 2010 app. Then we started introducing new services. So we started introducing our mobility service in Lync. It took us almost a year. Well, just over a year actually. And then you could do instant messaging, presence, call via work. And we added, in our later update, we added desktop sharing for iPad. Sorry, PowerPoint viewing and iPad. With Lync, we thought, well, we might want to sort of quicken this up, make sure that this doesn't take us more than a year. So when Lync was released, Lync 2013, we made sure the Lync 2010 app worked and did everything it did before. We even put a little optimization in there where the iPad could now join unscheduled meetings with PowerPoint viewing. And with the February 2013, or the CU1 update, we actually added not only did we launch the product, but now we launched it with full features. So all mobile modalities, video, VoIP, desktop sharing for iPad and tablets. One of the things we get asked a lot is, why don't you have PowerPoint viewing in mobile phones? So we've heard that and we're working on that and it's coming. To us, it didn't make much sense to put it in. You've got a limited screen estate, and if I'm doing a session on my mobile phone, it's going to be an audio or maybe an audio and video session. We didn't think people would actually do PowerPoint and desktop sharing on a mobile phone. Turns out we were wrong, or everyone is lying to us. It's either one of those. But we're working on that, and that's going to be added. So I'm not going to take you through all of these points. I think the most important points, and we're going to focus a little bit on that during the presentation, is our registration process has changed significantly to save battery, but also to make sure that if you're just away in your mobile phone, it doesn't just die after 3 days. We, of course, added the VoIP video. We also changed the notification channel. So we have this clearinghouse that we can use for events, the pop-ups on your mobile phone for Windows Phone. iOS has been funny about that. They sort of had it, and they didn't, and then they did, and then they didn't. So now we're actually using the VoIP socket on iOS, so we don't rely on any third party anymore. We can now directly talk to iOS to wake the application up. And we can use the pget event channel for Android. So the only clearinghouse we actually use is the clearinghouse we have ourselves. It's the Windows clearinghouse for Windows Phone. Another one that's really important that has changed is the layer 7 hardware load balancer. So if you had a hardware load balancer, it had to be a layer 7 hardware load balancer. It had to do cookie-based persistence, which turned out that just because a vendor said they did it, didn't mean it would actually work. So we had a lot of issues or challenges with that, and a lot of our partners had challenges with that. So we basically said, well, let's do this on the Lync server. Let's not do this on the hardware load balancer anymore. And Lync server is now responsible for managing connections, so no layer 7 cookie-based persistence anymore. With the one caveat, if you're still running Lync 2010 mobile clients for any reason, you're still going to need it. This is specifically for the Lync 2013 mobile clients. So let's take a bit of a look at those deployment steps we've taken to improve on the mobility platform. So first of all, we took a look at what we've done so far. So we thought, well, managing a complete platform for mobile and for the web platform doesn't make much sense. Let's make sure this is one single platform that we can maintain, regularly update, and does what it needs to do. So we've changed this and made this one shared API for this. We've made sure this was an integrated setup, so no more downloading separate packages and doing all kinds of strange PowerShell convoluted actions. It's now this one setup you run. It's actually installing Lync, and mobility will work. We had to add support for split domain. We're doing hybrid now, so we need to make sure that that works. We added things like a better support for auto-discover. And we made sure our mobile clients now completely leverage the Lync infrastructure. And I know it doesn't make sense when I say it, but I'll show you, and then it probably makes way more sense. So looking at a Lync 2013 mobility deployment, so what do I need to deploy this? I have my mobile user, of course. I need my forward and reverse proxy. This is usually the same device within your company. The important thing about a forward proxy is you need it when you go out to the internet, and you use your reverse proxy when someone comes out from the internet back to you. It's sometimes life's easy. Our edge, SIP, and media termination point, and we have our different pools internally. So when my client signs in, it doesn't sign in over the edge. It uses my reverse proxy. It uses the REST APIs to talk through UCWA, it's our UC Web API, and it uses the UC Web API to talk to Lync. This means that our mobile clients now actually use HTTPS instead of using SIP. The main reason to do this is when using SIP and your client goes to a hibernated state, it dies. The SIP doesn't take into account that your client might be sleeping for a while. as soon as the client gets back, we need to re-register. We need to set up all the new. We need to set up the new registration. We need to make sure that the client is accessible again. It's a big pain. If we use HTTPS, it actually supports a sort of a sleeping mode, and we can lengthen our timeouts, and we can actually start an HTTPS session. The client can go to sleep for a while. The client can wake up again, and the HTTPS session is still there. And we can still continue that session. So it's a conscious choice we made to make sure that if the client sleeps, because it's going to happen on a mobile platform, if it sleeps, your session doesn't die, and you don't get this experience where you need to sign in again, and everything seems broken. For your internal clients, we do not support, at this point, your internal client registering directly against your pool. Your internal client needs to go through your forward proxy, back to your reverse proxy, and basically your internal client talks to your pool via the internet. Who dares to take a stab at why we've done this? It's one word. It's not security. It's a good guess. It has something to do with it. This is one word I'm looking for. It's the nightmare of every Lync administrator when OCS was released. Authentication? No, it's certificates. Certificates. I know we force, so anyone that started with OCS in the time, that's probably the first time you got in touch with real certificates. We forced it upon a lot of people. So our pool will, in most cases, will be running internal certificates from an internal CA, and your mobile client doesn't trust us. So we have two choices. We can either force you to deploy your internal root cert to all your mobile devices, which is going to be fun for your IT department, because everyone is now coming in, oh, I bought this new phone, could you please install the certificate? And sometimes that works, and sometimes it doesn't. Or we can simply redirect the client to go through the forward proxy, then the reverse. It's going to hit public certificates, no problem at all. We thought we'd do you a favor and use the forward reverse proxy trick. As far as bandwidth is concerned, these are very small HTTPS calls. In the end, it's simply signaling. So if you're using an intelligent forward and reverse proxy, it doesn't even use your internet connection. It just uses a loopback. So it doesn't really add any bandwidth, but it saves you from a lot of deployment pains. So that's the thing we've done. Now the question is, from a lot of customers that are saying, we are not doing any external communication. Everything's internal. We don't have a reverse proxy. We don't have an edge. Well, you can guess. This is not going to work. There's a solution for this. Make sure your external URL that you can set up in Lync is actually your internal URL, because the external URL is the one we use when connecting the mobile clients after the auto-discover URL. Set this to be the same as your internal URL and make sure your clients trust the pool search. So maybe you have to use public search on your pool and you can get this to work as well. There are some guides that use, there are some registry hacks or some XML hacks, and just don't do that. Use the simple trick of external equals internal URL and you're done. So some of the interop, the Lync 2010 client runs on Windows Phone 7.5 or higher and can register against, surprisingly, Lync Server 2010 and 2013. The Lync 2010 app also runs on Phone 8, can register against 2010 and 2013. And the other one is the Lync Server 2013 app only runs on Phone 8 and can only register against Server 2013. Something to take into account. So some of our interop, you can all download the presentation. If you have any questions about this, see my email address. I'm not going to... Yes?
The Lync client in the PC is compatibility with 2013 Lync client against Lync Server 2010. They made their this choice.
Yes.
In the mobile phone, it's not.
Correct.
Why is the difference? Why did you make different
So the question is why is the Lync, why is the desktop app in 2013 compatible with the 2010 server, and why is the mobile app in 2013 not compatible with 2010? I don't know. That's the honest answer. I can guess. So in most companies, you'd have your clients installing the apps, and in most cases, installing an app would be an admin sending out an email, install this app, or someone in your company asking you which app do I need for the server, which is a different platform than when using the desktop apps, where an admin completely controls the deployment of those desktop apps.
It works like this, that if people is curious,
Yes,
Lync 2013,
people are curious.
install it, and then it doesn't work, and there was another session, the guy was, or maybe it was you saying that they regret because this app was used like very bad rate because it wasn't working, and this guy said that it was the user's fault, but I would say it's Microsoft's fault.
Yeah, so we can talk about this all day. In short, I don't know. I disagree with it's bad that the users are doing something wrong. Maybe we've done something bad. From a technical point of view, because we're using the UCWA, our 2013 app simply cannot talk to mobility servers in 2010. It's simple as that. We would have to do a lot of reverse engineering, crazy things to make it work.
The mobility service has been really completed and depends on Edge 2013, if I'm right.
No.
Sure?
Yes.
I had to set up the 2013 Edge before I could connect the mobility client. It was not possible before.
So the Lync 2013 mobile client connects to a Lync 2013 pool.
Yes, that's true, but the mobility service is also on the Edge.
No, the push notifications are reliant on the Edge. I wasn't there, so I'm sure you're right. Let me say that first. It's hard for me to disagree. It shouldn't. So I don't know why. Send me an email. I'd be happy to talk about that. So let's move on for now. It should have worked. And we've heard from customers that in most cases our app and our deployment actually works. So I'm happy with that. So I'm happy most of you had a good experience when deploying this, and I'm sorry it didn't work for you. So some of the policies we've implemented. So we'll take a look at the IT admin and user perspective for this. So IT admin is actually able to change things like, are you able to use the mobile client? Are people only allowed to do VoIP and video over Wi-Fi? Are they allowed to use this over 3G, 4G? Maybe we want to control the amount of data that we're sending over our paid-for data connections. We have an option to enable or disable push notifications. Maybe there's a reason you don't want this. And of course, the archiving is controllable via policy. The user also gets almost the same options, whether or not they support push notifications, phone book access, photos on or off. So because Lync can be a complete dial pad replacement, we can actually connect, we will actually connect to your local phone book in your phone and use that local phone book to call existing numbers in your phone. And now use your Lync or use Wi-Fi to call those people. Something people can turn on and off, and one of the other improvements that I particularly like. So I used to have 2 mobile phones, but a cab took care of that. I have separate mobile phones, separate Lync mobile clients, and each mobile client I can specify a different mobile phone number that I'm using. So when I use call via work, I used to have with Lync 2010, when I used call via work, I would use Lync on phone 1, and now phone 2 started ringing, because it didn't support the different phone numbers. Now each Lync mobile app can use a unique mobile phone number. which is convenient for people with multiple phones, multiple devices. So one of the questions we get asked a lot is, could you explain a little bit more about capacity planning? So I can explain something about the mobility capacity plan. It's better than nothing. So when we plan for adding mobile clients, we start, well, how many clients do we think we're going to add? Okay, we're going to add, let's say, 4,000. Okay, so what am I capable of running today? I need additional capacity, and then I'm going to check, well, it's my key health indicators, does it actually work? I'm pretty sure this doesn't help you at all. So let's get a little bit more detail on this. So how do we estimate our mobile usage? We use a user model. We're still building the capacity planner. It's really hard to build one, we found out. But this will be a part of the capacity calculator where you can actually add the amount of mobile users you'll be having. So in short, you take a look at user mobile model. How many users am I expecting to have on this mobile platform? What am I currently using? How many gigs of memory? What's my current capacity? What capacity do I have left? Then I need to do this nice little calculation. I need to take 0.5 gigs plus the amount of active users divided by 2,000. That's for our memory. CPU is the amount of active users times 0.0044. And I hate to be the guy that had to come up with this number. But we calculated, this is the number. So let's get a little bit more concrete on this. So let's say I have a deployment, 8,000 users, a 2 front-end pool, because they didn't use the reference topology. You should always use 3 front-end servers. 8,000 users, 4,000 users per pool. Our CPU usage is less than 60%. And we have 6 gigs of available memory per front-end. So now we're going to deploy mobility for all users. Every user has 1 device. And we use a user model similar to the 2010 capacity model, which means that every front-end is going to service 4,000 mobile users. So if we calculate this, this means that to get to this 4,000 number, this was 4,000 divided by 2,000 plus 0.5. This means 2.5 gigs of additional memory we need. And we have 18% additional CPU. This was the amount of users times 0.0044. This means that at this point my CPU is running at 80%. If one of my front end goes down, I'm done. My additional front end can't handle this anymore. It's now running at 160, and although that works in movies, it doesn't work in real life. So we need an additional front end. And you get this 2,667 mobile users per front end, and now since our 70% CPUs are running at 70%, we feel better about this failover scenario. For those who are good at math, you can see why the capacity planner is kind of hard. We were running at less than 60% with 2 front ends. Now we have 3 front ends. So you think, well, 2 times 60 is 120, divided by 3 is 40%. So now we should actually be running 40% CPU per front end. Yeah, it doesn't work that way. There are a lot of processes to take into account. So the whole graph of saying, well, if 60% on 2 front ends, that means 40% on 3? No. A lot of difficult calculations. So the guy building this calculator is I think he's having nightmares about Lync by now. So how to deploy, and I won't bore you with 2010 because that was, once again, not the best experience we could think of. Install the update, enable mobility, and you could select, do I want to use push notifications or not? If I do, I had to add push.lync.com as an edge provider, and I'm done. That's it. Mobile clients work now. And we added the synthetic transactions to test this deployment. As far as the cloud's concerned, we're all in. So if you have a cloud deployment, all you need to do is install the mobile app and it will work. Some points on monitoring. We still fully support the performance counters and the alerts, so this is something that you would need to do when you're doing this capacity planning. Sure, I've listened to Cornel's session. He said every user 0.0044 CPU, and he had this nice little trick with the memory. I don't trust this guy, and rightfully so. We have to check if he's right. So you can use these performance counters to do that. And you can actually check the impact by using the synthetic transactions or use any of our stress kit tools. So let's take a better look at this architecture that we're using. So we said we're doing this REST API over UCWA. It's actually, so we call this real-time communications over HTTP. So looking at our Lync server, you'll see our AVMCU, responsible for our conferences. You'll see our SIP proxy. It's actually the SIP register, SIP proxy. It's where our clients register against. RTC database, we have our UCMA. This is our programmatically sort of our SDK for service. We have a web ticket for issuing certificates. UCWA, our discover URLs, and our other web components on our web layer. And we add any form of web proxy, server authentication, any throttling on top of that web layer. And this is a big oversimplification of Lync. If you'd like to know more, please visit Microsoft Certified Masters. But this is, in essence, the components we use when using our mobile clients. So on the right, you'll see our Lync mobile app, which actually has a client application layer. And it has our media stack on board. So when talking, when we start out setting up our conversations, we first have to find out where's Lync. We'll do this by going to autodiscover.zipdomain. And this is not an anonymous connection we make. We actually have to authenticate to get all this information. And this autodiscover API returns to us all the information about Lync. Like where's our UCWA server. So our internal client can use autodiscover as well, or can use a DNS record and can connect to our AVMCU, UCMA if needed, through our SIP proxy. So once again, while the desktop app uses SIP signaling to talk to Lync, it's the mobile client that uses REST APIs, which is basically SIP signaling, but over HTTPS. Which means that any updates, which we normally use with notifiers and invites over SIP, we just use our HTTP channel to talk to our mobile client to get any of these updates out, like our session description protocol or any urgent update. As soon as we start looking at media flow, this traverses the normal path, so no more HTTPS encryption, no more HTTPS encapsulation. It's just our media stack that behaves exactly the same as our desktop client would. So full use of Turnstone, full use of the Edge servers, full use of the AVMCU, which is why our mobile client can just participate in conferences, can participate in peer-to-peer calls. One of the most asked questions is where does media go when both my mobile client and my desktop clients are internal? It stays internal, doesn't traverse the edge, doesn't do any funny stuff. It's the same media stack we use in our desktop applications. It's just the signaling that's packaged in HTTPS.
Sorry to interrupt you, but the block on the TechEd says still flows through the Edge interface.
It can flow through the Edge interface. Then I'd really like you to use the little button, report a mistake, and your name get listed that you found a mistake in our documentation. I appreciate the feedback. I'll take a look at that. It doesn't. I can tell you it doesn't traverse the Edge server. Only if the mobile client, and I think that, so we haven't done it's too bad it's being recorded. We don't always do a terrific job in explaining the scenario that we're now configuring on TechNet. So that means that sometimes we're talking about scenario A, and then we say things like, well, we mean that the mobile client's outside, and then the media would traverse the edge server indeed and go to the VMCU. And then a couple of lines further, we then talk that the client is inside, and then stuff gets really hazy. So it's a documentation error. I can tell you, and I would encourage you to check whatever I'm saying by doing by sniffing this or doing a wire trace. Yes, it stays internal. The media stays internal if we can. If there are firewalls between, yes, sure, we could traverse the edge server. And I've got some pretty cool slides on that. One of the things, so if you're using an iPad or any form of tablet, we will also support any form of desktop and PowerPoint sharing. So the big mystery behind Lync Discover, why do we need Lync Discover? We need to find out where all of our information is. So we need to find out where UCWA resides. We need to find out where any of our Lync components reside. So instead of adding additional DNS records, we've decided to go the Exchange way. They've used Auto-Discover for a while now. It's been very successful for them. So we're using the Lync Discover URL as well. So the first thing your mobile client is going to do, linkdiscover.zip domain, and we're going to find out where's UCWA. And this is extremely important, especially when you're going to things like a hybrid solution, maybe a cloud solution. So where's this UCWA located? And all Lync Discover is doing, and this is something you can use Fiddler or you can go to the URL yourself. It basically gives you back an XML file with the location of all of your services, like the UCWA server, but also your edge services, your local media edges, your Lync server pool name, all that stuff. And because we know that could be considered to be security sensitive, you have to authenticate to get this information. We're not just giving it away. How do we actually find this UCWA server with Lync Discover? And we use the example of hybrid, because a lot of people ask us, how do we do this for hybrid? So you'll see on the left your local deployment. On the right, you'll see your Office 365 deployment. We've connected these using DirSync, which means it's now a hybrid deployment. We share this one SIP namespace, which could be, which in this case, contoso.com, for both our on-prem and online clients. So when Alice tries to connect to the UCWA server, and Alice is actually a user that's in the cloud, Alice uses linkdiscover.contoso.com, which is hosted by our internal pool, goes through the reverse proxy, asks the pool, could you please tell me where my UCWA server is? The pool does a lookup, finds out Alice is actually an online user, formats this in a nice and neat XML file, talks back to Alice, says, well, this is your UCWA server. This is where your mobility services reside. You're actually a cloud user. Please go there to register and to run. So Alice now uses our GeoDNS service from Office 365 and connects to the reverse proxy to our online Lync server. Sometimes life's easy. This is how we do a hybrid deployment and find the correct service. This is, by the way, the same for the desktop client or tablet client. That's why we use the Lync Discover URL, because we can be way more specific about which services you need. If you open the XML file, you'll see there are about 25 different services we give back to the client. Imagine deploying 25 different DNS records for all those services. It's going to be fun. So we thought we'd keep it simple. So mobile presence, with Lync 2010, 3 days of inactivity equaled offline. That's how Lync 2010 worked. And even worse, the Lync 2010 3 days of inactivity meets online actually consumed a lot more resources than our Lync 2013 solution. So on Lync 2013, you can actually be away for 10 days before we have to terminate your registration. So how do we do this? So on Lync 2010, you would connect to our mobility service, and we would create a user endpoint. A user endpoint, virtual endpoint running on the front end. It's something that my front end would now need to maintain. So we need this virtual endpoint because the clients can't really, the internal clients or the other clients can't really talk to this mobile device directly. We have to proxy this request because this mobile user will be roaming, it will be changing data networks, the registration will be changing all the time. So while your internal client has an IP address, even though he might change access points or whatever, the IP address will stay the same during its registration. For mobile client, that's not the case. It will be hopping, changing IP addresses, changing registration, changing Wi-Fi to 3G, LTE, etc. So we need this virtual endpoint. If you have to maintain one endpoint, that's fine. Think of our example, 4,000 endpoints, resource consuming. So as soon as we went inactive, which means that I don't do anything for 5 minutes in this app, or I use a different app, my service would know this. Sorry, my service wouldn't be notified, but I'd guess. We'd go to a way, we know that this person isn't using the app at this point, and the user endpoint remains active. And if Alice doesn't do anything for those 3 days, we then kill the endpoint. So if I open my Lync client once, then use my home button, don't do anything for 3 days, I'll still spawn this user endpoint for 3 days on my pool. We thought that might not be very efficient. We might want to improve on that. So before I forget, if Bob wanted to find Alice after those 3 days, they couldn't. They need this user endpoint to be available to find Alice. So we thought, let's improve upon that. So when we sign in, we actually sign into UCWA. We still create this user endpoint, but we also create a static registration. Now, as soon as we go to inactive, we know Alice is inactive. And because we have this static registration, we don't have to keep track where she is exactly. So what we'll do, we'll kill off the user endpoint. We still have the static registration, it's just a line in our database that says, we can find Alice this way. And if Alice isn't active for 10 days, we'll clean it up. It's more of a housekeeping thing, because if Alice hasn't used Lync for 10 days, she probably won't use it for 11 days either. We could keep this indefinitely. It's not resource consuming, doesn't do anything, it's just a line in our database that says, if Bob wants to invite Alice, that's where we can find Alice. We'll spawn up this user endpoint again, user endpoint is available again, and we can use this user endpoint to now find Alice and wake up the client. So we've become more efficient with that. We had a question about it. Is there a way to check how many endpoints already? Is there a way to check how many endpoints you've got available, how are running at this point? There is, but I don't know by heart what the exact PowerShell commandlet is. If you send me an email, I'll find that commandlet for you. So what? Where do you get the logs from?
The mobile client, the
yes?
user sign out.
Yes?
Does the mobile endpoint and static registration get clean?
So if the user so the question is, if the user signs out, does the static registration get cleaned? Yes. Yes, so if a user specifically signs out, and that's the same for the 2010 client, by the way, if a user makes the conscious decision to sign out, yes, we delete any endpoints. The thing is, it never happens. No one ever signs out. Because if you're on a mobile client, what do? Press my home button and app is gone. And if the app is gone, I'm not using it, right? I'm signed out. That's...
But if I turn off the mobile, is the app automatically signing out in the stage?
No.
It's just like...
Yes, we kill the app. It's the same for any application. Phone off, app killed. Phones don't really do graceful shutdowns. They just kill current safe states, unfortunately. So VoIP on mobile. So when you were deploying the 2010 service, you had to add the Apple notification service and all those different notification services to make sure that if your app was in the background, you'd actually get a pop-up saying there's a call for you and I am for you. That's what we actually mean with the notification mechanism, with the pop-up. We need to show you that there's a new message for you because the application itself is in sleep mode. The application itself cannot tell you this is what we're doing. It's a notification event that goes out. And we've added some new, we added some extra support for that. So while we still do push notifications for Windows Phone, which is a really nice thing because we own the push notification service, it's ours. So whenever we make a change to it, we can easily make a change to Lync to support this. We'll do the VoIP socket for iOS, which is something that's just a part of iOS. And we use the pget event channel for Android, which means that we're now not reliant anymore on any third-party clearinghouse. We'll just use the built-in APIs, that as soon as they start changing those, they're in a bit of trouble. So how does VoIP work on our mobile clients? So I'm on my iPhone and I'm going to get a VoIP call. So I'm registered, or this is supposed to be, I think it's a Samsung, because we use p-event get channel, that's Android thing. So it looks like an iPhone, it's probably a Samsung. The p-event channel now we're registered, we've got this p-event channel running to the pool over UCWA. Bob makes a call, he's on pool 2 or pool 1. He wants to call Alice. Alice gets a notification over this channel. We get this pop-up, hey, Bob tries to call you. See the pop-up, we can unlock the phone. Accept the call, deny the call, whatever we like. In this case, we accept the call, and the call is accepted. Bob gets a notification, your call is accepted. Well, we actually see establishing call. When the call is getting established, we'll use media flow. So in this case, we'll go through the edge, or a direct connection, or whatever that person is at that point. We could reverse the edge, we could go direct, we could go basically all the media stack options that a normal client has, mobile client has as well. So we fully support NATs, we fully support firewalls in between, port negotiations. If your desktop app works, your mobile app will work as well. Yes. Yes.
You cannot, like if I receive a standard call and the phone is locked, I can answer the call directly.
Correct.
In your case, you must unlock the phone.
Correct.
And you can't get through this in any way.
No. So the thing is, you have to unlock the phone because it's an app. It's just plain and simple reason. We can't get past that because we don't own that portion. We're not allowed to make an app that bypasses the lock screen. We'd like to, not allowed to. So how does this push notification business work? So we're using a Windows phone. Bob makes a call. And now, because we own this push service, we go to the edge. The edge has a subfederation with push.lync.com, which is our push service. Our edge, it's actually, and the funny thing is push.lync.com is just our Lync edge for Office 365. This edge server now talks to our PNCH, which is our push service notification clearinghouse. Goes back to the device. The MPNS is the Microsoft push notification service. And they send a push notification service to this specific device saying, well, so that the nice pop-up comes up, there's a call for you. And you'll see this, there's a Bob for you from Anna, so apparently Bob is now called Anna. And we can answer the call or disconnect or whatever we'd like to do. As soon as we accept the call, we don't need the push notification channel anymore. The push notification was just for the pop-up. We have revived our HTTPS channel, and this is why we like HTTPS, because we can just revive it if we would have SIP, we would have need to sign in again, do all that stuff again, wait, so we've pressed accept. But now we have to sign in, wait for everything to be connected, wait till we get authorized again. So this could add 10 to 15 seconds. HTTPS, revive it and we're good. Accept the call and we'll get a media channel. So something about the push notification clearinghouse. I think our official statement is the one on top that I never get to learn by heart. It's our online service to light up background applications on Windows Phone 8 to deliver messages and VoIP calls. So yeah, I sort of did it by heart. Something for your reading pleasure, because we're never really clear on what is this push notification clearinghouse. We just mentioned our notification that we use it, and this is basically what it does. And how you connect to it. So by default, it's not there. You have to add this to your deployment, so documentation how to add this push notification service. If you don't add the push notification service, it means that there is no, if your client receives a call, they have to be in the Lync app, or else they won't get a pop-up that there's a new call. Something about the VoIP call preferences. So we can use we find 3 different modalities: Wi-Fi, cellular data like 3G or LTE, and PSTN. We do not support handovers. So if you're on Wi-Fi, you go to cellular data, that doesn't work. Cellular to PSTN doesn't work. You need to rebuild your call. Is this a problem? No. Is it inconvenient? Yes. Is this the same with every vendor out there? Yes. We've seen some of our competitors that say we do handovers. That's right. I've seen a demonstration of that, which is basically I go from Wi-Fi to cellular data. My call now is lost, so no more call for me. My server understands that, and now he starts to rebuild the call. So in about 15 to 20 seconds, my call is reestablished. Okay, so I now support handover, but I don't think that's the best solution at this point. So we're working on how we want to fix it. We want to do something like that because we think it's kind of hard to explain to your users, well, if you're using your mobile phone, you shouldn't really go out of the access point reach. So that defeats the purpose of a mobile phone. So we are working on that. We're trying to see how we can make that experience better. For right now, it's simple. We don't do any form of handover. So some of those voice call preferences, if we set either the admin policy or the user policy to require Wi-Fi for calls, this means if we set up a call and we used to be on Wi-Fi, we're now on LTE or 3G or whatever you're using, we have Alice that has the setting require Wi-Fi for voice over IP, which is by default off. So by default we can use the 3G connection. The require Wi-Fi for video is on by default. So bot makes a call. The pool knows, well, wait a second, Alice isn't on 3G, isn't on Wi-Fi anymore. And she had this policy that she needed to be on Wi-Fi to receive a call. So let's not do a call. At least let's not do a VoIP call. So we're going to do a fallback. This number you've typed into your mobile client, that this is my PSTN number. That's the number now being used by a pool. Your pool checks if the voice policy actually allows dialing of this number. And if you have more questions about voice policy at 12 o'clock, there's a big session from Thomas and me about voice policies and how that works. So the pool does a fallback to PSTN. We go to the mediation server, media gateway, PSTN GSM, network, and we find the mobile client. Now the beautiful thing is, because we still have this signaling channel, this HTTPS channel between the mobile client and our pool, we actually trigger the Lync app that they should be expecting a call, and you will see, even though it's a GSM call, the experience for the user will be the same, and the user will see it's a Lync call. Lync will pop up and show all the Lync properties for this particular call. So you can see the experience is the same. Yeah, media channel. So that leaves us with our rich roster. One of the, and I took this specifically because it has some, it shows one of the investments we've made on saving on data. So our rich roster is actually the, I have a nice, so that's this thing, right? It's the overview of who's in my call, conference calls, who are there, who are the people that I'm talking to right now. So what have we done? We use this to show what kind of meetings you have, who's the active speaker, the modalities we're using, who's there, including pictures. So we've implemented something called UI virtualization. So instead of keep sending you all the information and just keep refreshing this rich roster, we're going to send this to you once. And as soon as you have this rich roster, we're only going to send you updates. So we will not refresh, we'll just send you any updates there are. And we'll bind those updates, which means that any information you have local on your phone, we'll reuse that. And we'll only send you the missing information that you don't have. If you have the pictures already on your phone, we're not going to send you new pictures. Why update pictures if you already have them? Why update titles if you already have them? So you can see that if you look at the information, we'll only send you the information you specifically need in this case. One of the things we've done to save a lot of bandwidth. So it gets us to the last slide where we had a question on about the troubleshooting. So we have a client-side troubleshooting, which is something you can enable client logging on the mobile app. Once you've done the logging, there's a share via email option. And you can load these log files in Snooper tool. And Snooper will give you a nice overview. So with the newest version of Snooper, we'll actually show you the nice table that does that shows all the endpoints and all the messaging that goes between the endpoints. And once again, we'll talk a little bit more about it at 12 o'clock. The server logging you need is CLS logger, or for those who can't say their goodbyes to OCS logger, you can download the resource kit tools and you get OCS logger again. UCWA, Web Infra, Collab, and S4. Those are the 4 points you need to log to actually get all the logging for the Lync mobile clients. Which means that we're running well within time. Yes?
What's the difference of the logging from the Lync mobile client 2010 between the client 2013?
So what's the difference in logging? I believe we log some additional values. I believe the 2010 only did the web updates, and the 2013 does everything the client does. But it's been a long while since I used the 2010 logging, so I might be lying there. So I can't give you a definite answer on that. I believe we've added some additional logging, specifically for voice and video on the 2013 client.
Right, in 2010, I can see the log on each editor, and 2013, I must use.
Oh no. So if that's now I understand. So the question sort of comes down to why do I need Snooper tool for 2013? That's the question, right? You don't. You can just use Notepad++ or Notepad, WordPad, whatever you'd like. If you use Snooper, it just becomes nice and shiny, and you can see you can trace specific calls, and it's way easier. That's basically it. If you want to look at it using Notepad, it's not encrypted. There's nothing going on. You can use whatever tool you'd like. Snooper is just easier, and I'm kind of lazy, so I like the easy method. So our updates. So what are the main points about what I'd like you to take home. Switch from a mobility service to a UC Web API that's usable by both the mobile clients as well as anyone that actually wants to do any form of mobile development, web development, including voice and video. We do not require cookie persistence anymore. We allow you to manage your mobile clients, like whether or not allowed voice and video, to allow integration into any form of message saving, archiving. We do HD photos now on mobile phones. Since we know the mobile phone is a way more visual platform than your PC is. If someone calls you, you'll get the screen-filling picture. That has to look nice. We added VoIP and video support, sharing for the platforms that are relevant for sharing. And I think the longer lived registration, less resource consumption, some of the big updates we've done. That means we now have approximately at 10 minutes, 10, 15 minutes for questions that you might have, or you can get coffee earlier. Before we start questions, the thing I have, if there's related content, there's also a deep dive into UCWA. I think we've already done that session, but if you'd like to know more about UCWA, Albert Kooijman has done some really good sessions about this. I encourage you to see some of the sessions. He has some really cool unified communications business-enabled processes, communications business-enabled processes which show you things like, I think he does the taxi driver demo, which is actually pretty cool. It's completely built around the UC Web API, and you'll see a demo around a cab driver getting a notification from someone on a mobile phone that wants to go somewhere, including voice, video, map integration, some really nice stuff, completely built on the UCWA. We have 2 certification exams for Lync. I will be probably at the Lync booth somewhere today, for those who haven't been there yet, or else one of my very capable colleagues will help you. And we'd like you to fill out evaluations. It's very important, evaluations, because in the end we get rated on those. So that brings me back to Q&A. Does anyone have any questions they'd like to share with the group? No questions? One question.
I would like to know, you talked about, you showed a picture which shows the basic structure, the architecture of the, basically how the client works.
Mm-hmm.
The UCWA and the authentication and the web proxy.
Yes.
And I was wondering if there's a reason why the Android client isn't using NTLM like the other client does. Why haven't you chosen another path for that?
Why doesn't the Android client use NTLM?
Yeah, because it's stated almost everywhere on the internet that all the mobile clients are using NTLM. And that's from MVPs, etc., but this isn't true.
To be fair, I don't know. As far as I knew, the Android client used NTLM.
Right.
I wouldn't know what else they would use.
They're using the MEC service. All the clients, when they do a sign-in, they first go to the auto-discovery like you
Sure.
showed, and then they do a post to the web ticket service.
Yes.
And the Windows Phone client, as well as the iPad client, sends a post there using NTLM, the NTLM
Yeah.
session starts. Before they do that, they go to a MEC service, which is a part of the web ticket
Mm-hmm.
service, to get information about where do I
Yeah.
authenticate. The Android client, instead of going to the web ticket service, then does a post to the web ticket service, but to the next part, sending the password in base64 encoding.
That's bad. We shouldn't be doing that.
That is, at least in my Lync 2013 environment CU1, my Android client is doing this.
Which Android client are you using?
Samsung one.
No, but
Yeah.
are you using one of the beta ones or actually the released one from the market?
From the market, so
Let me look into that. If you can give me your email address, or better yet, if you can send me an email, I'm going to test it. So I test a lot of stuff on Android, but I haven't tested that specific thing. But if it's sending its password in clear text, no, we should definitely not be doing that.
I hope I'm wrong.
Yes, everyone can send me an email. So I'll just ignore some emails. It's not true. I would never ignore an email. Yeah, please, kbullens@microsoft.com. Please send me an email, and I will look into that. I'll email the PM and see what's going on there. I think you can even earn money with finding bugs. Maybe you just earned money. Yeah, let me look into that. That's bad. Any other questions? Do you all want to go get coffee and the rest of you storm the podium and ask me questions that you don't want to ask here? That's fine too. So everybody, you're excused for the day. It's like college.